Good afternoon. Good afternoon. All right. Today is May 17th, the day of the admat exam in 2024. And this is the paper 2. So a student of mine sent it to me and asked me to work it out. All right. I guess that is the norm these days to see the paper worked out on the day of the exam. So a student can know right away what the grade is. All right. I'm going to do this one video at a time. Right. So some persons are interested in particular questions. And so I'm going to do one question for each video. All right. So I'm starting number 1 with this video. All right. So this is the paper. All right. So the first question said, we have to determine the other linear factors of this polynomial. It's a cubic polynomial, and they're saying that x minus 2 is a factor. There's a standard remainder factor theorem where we are able to divide a polynomial by a factor that is of order less than it. So we're just going to do the long division to see what other factors are. And our quotient is going to be a quadratic. So we divide it with a linear, we divide a cubic with a linear. So we're dividing x minus 2 into 3x cubed plus 8x squared minus 20x minus 16. It's a standard process. So it's this term divided by the x gives us 3x squared. 3x squared. Then it's 3x squared times these. So we're going to get 3x cubed minus 6x squared. Then we're going to be subtracting. So this minus this, that's gone. This minus makes it a plus. So we're operating with a plus right here. And then it is this 8x squared plus 6x squared gives us 14x squared. So 8 and 6 is 14x squared. And then these are not subtracting anything, and so they come back unchanged. That is 20x minus 16. Then I'm dividing this by that x. And I'm going to get minus 14x. And it's minus 14x times this gives us give me that minus should be plus, not plus. I'm dividing this by this, I'm getting a plus. Okay, not a minus. It's actually a plus. My mistake. All right, so that's a plus. Okay, it's a plus. Okay, so it's plus this times these now. That will give me 14x squared, and I'm getting negative 28x. And I'm going to be subtracting. So again, this minus makes it a plus. I'm going to put a small plus here. And so it becomes a plus 28 minus 20x. 28 minus 20 is 8. So I'm getting 8x minus 16. Run out of space. Let's make this smaller and zoom in. All right, so make that smaller and zoom in. Then it is this 8x divided by x is giving me a plus 8. And it is positive 8 times these, giving us a 8x minus 16. We'll subtract that, we get a remainder of 0 because we were dividing with a factor. So this is our quadratic factor of the same expression. And what we can do is factorize it where it is. So I normally say to the student, factorize it where it is on top there. So we can write the final answer. So what are the factors of this up here? What are the factors up here? All right, let's factorize this. So this becomes bracket, 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 bracket. Now the factors of 3x squared can only be 3x and x. So I need factors of 8 to go here and there. And it's positive factors. See, everything is positive. All right, and I want middle term to be 14. So what can I try? I can try 4 and 2. I look at it, I see it's 4 and 2. Because this time this is 12x, this time this is 2x, they add to 14x. So those are the proper placement of those, and the signs are positive. All right, so the signs are positive here and a positive there. All right, so I'm now my polynomial will then, these are the other two factors. All right, those are my other two factors because I have this one. So these are my answers right here in red. My other two factors. Other factors are in red. That is it. All right. Next question says, hence, we have to simplify this expression. So firstly, we want to write this expression as a product of that linear factor and these other two factors. This is going to be a some cancellation thing, right? So let's go back here. All right, let's copy the factors that we have up here and copy it down here so we can just use it. So we're going to be using these two factors. Copy them, paste them down here instead of rewriting it. Those two factors along with this factor right here, the x minus 2, the x minus 2. So those are the three factors of this expression. I'm just going to change everything to blue. So that's what the numerator becomes first. And I'm dividing that by this, which is the difference of 2 squares. This expression becomes x minus 2 times x plus 2. And then I'm multiplying that with these, which x plus 2 over x plus 4. And I will look for stuff to cancel. All right, so this x plus 4 cancels this x plus 4. And this x plus 2 cancels this x plus 2. And then this x minus 2 cancels this x minus 2. And all we are left with is that 3x plus 2. So this all becomes equal to 3x plus 2. That's my answer. So far, so good. Very easy. All right. Next part here says, this equation has roots alpha and beta, where k is a whole number, but to determine expressions for these. They're going to be in terms of the k and the w. Oh, problem. Be careful. So when we're picking up the b and the c, the equation has to be in the standard form. So we have to transpose this 10, right? Sum and product of roots as we know it, our equation has to be the standard form, which is ax squared plus bx plus bx plus c equals 0. If you do not pick that up, problems. All right? If you did not pick that up, we have problems. So our c is actually negative 25, not negative 15. All right? So we have to transpose it to this form. Very important. That's a quadratic equation in the standard form. Wow. So this is some sugar. So this is the first sign of sugar on this paper. All right. I can assure you a lot of persons not going to transfer that 10. I can assure you of that. So that's the first place a lot of persons going to make mistakes. Let me put this in red up here. Let me put this in red. So you see, oftentimes we have to read carefully and pay attention to the details. So this equation, I'm going to rewrite it in the standard form, which is kx squared plus x, and it's going to be minus 25 equal to 0. A lot of people are going to do this question and believe they are correct, and they're going to be incorrect. All right. So they want the sum of the roots, which is alpha plus beta. So let's write it here. So alpha plus beta becomes minus b over a. Now the b is 1 because the coefficient of x is 1. Let me shift this down and write the a and the b and the c. And then we can put that here because it's going to be a value. So from this standard form, let's write the a's and a, b, and c in a different color. So the a is going to be k, which is the coefficient of the x. The b is going to be 1, and the c is going to be negative 25. Negative 25. C is negative 25. A lot of persons are going to use that negative 10, I guarantee you. All right. And so the alpha plus beta here is going to be minus b over a, which is going to be minus 1 over the a, which is k. So that is the alpha plus beta minus 1 over k. And then the alpha beta is simply c over the a, and the c is negative 25. Negative 25 over k. All right, so that's my two expressions. And this one says, given that alpha squared plus beta squared is 61 over 4, they want us to use the expression to determine the value of k. And remember, k is supposed to be a whole number. So we pay attention to that. So if we get more than one value for k, we have to choose a whole number value. All right, so let's go. So remember now, this alpha plus beta squared expression, I'm going to rewrite it. So this side can be written as alpha plus beta all squared minus 2 alpha beta. That this is equal to 61 over 4. So we're solving this now. What it is that I want to drop this expression is the alpha plus beta inside here for the alpha plus beta. I want to drop this expression right here for the alpha beta. That's where the mathematics will come. I don't want to solve for k. All right. So this becomes, we can basically just square this, we're squaring the alpha, we're squaring that expression there. So I'm just going to write 1 over k squared. Because the negative 1 squared is positive. So it's going to become 1 over k squared minus, and then this is 2 times this expression. So firstly, the minus is going to make this positive. So it's going to be a negative 2 times negative 25, going to become a negative 50 over k. Negative, going to become a positive 50. So it's going to become a positive 50 over k. And this is all equal to 61 over 4. All right, let's just check this. So this expression, when we square it, it becomes that. And if we multiply this by negative 2, multiplying that by negative 2, becomes a positive 50 over k. Good. And so we're solving this equation now for k. Let's look at the space. Okay, good amount of space. So solving this now for k. So firstly, I'm going to multiply 2 by the 4. I can multiply 2 by 4 and k squared. Just get rid of this denominator. So I'm going to multiply 2 by 4k squared. That will get rid of all these fractions. So I'm going to multiply through by 4k squared. If you wanted, you could go step by step. So I'm going to multiply this by 4k squared. The k squared is cancelled. I'm going to get 4. When I multiply this by 4k squared, 4 times 50 is 200. And k out of this cancels a k out of the k squared. So I'm going to 200k. 200. Did I make a mistake? No, this is supposed to be a 4. 4. Come on, Mr. Shaw, don't give it away. Let's go again. When I multiply this by this, I'm going to be left a 4. K squared cancel k squared. 4. So when I multiply this expression by this, 4 times 200, 4 times 50 is 200. And then k cancels one of that k. So I'm going to get 200k. 200k. Then that becomes equal to, this 4 is gone, and so I get 61k squared. That becomes a quadratic in k. Let's transpose everything over that side. So I'm going to get 61k squared over there. 61k squared. 61k squared minus 200k minus 4 equals 0. So this needs to be factorized. Is this a prime number? I think that's a prime number. Can I test it? 61, 1, 2 and 2. That's not giving me 200. It's about 4 and 1. That's not giving me 200. So let's see. I'll use a quadratic formula. But let me see if what we have here is correct first. 61 over 4. Let me just check this. That's definitely a negative 25 for the C. And the B is 1 and the A is K. And that's minus B over A. So it's minus 1 over K. And that's C over A. So that's negative 25 over K. And then this equation that tells us, and this side becomes alpha plus beta squared, alpha plus beta r squared minus 2 alpha beta. That's what this side is. And that was squaring this expression here. That's the alpha plus beta 1 over k squared. Then I'm multiplying a negative 2 times this. So I get a positive 50 over k. And that is all equal to 61 over 4. Just double checking what we have so far, because the number's not looking so friendly. And then I'm going to multiply it by 4k squared to get rid of these fractions. And so the first term there becomes a 4. That's correct. And 4 times 50 is 200 times k. And then the 4 is eliminated, it's k squared. Transpose minus minus. All right, so I'm not getting this as factor. So maybe I'll just drop it in the quadratic formula and see what happens. So the k is going to be minus b, which becomes a 200, using the quadratic formula, plus or minus the square root of b squared, that's 200 squared, minus 4 times the a, which is 61, times the c, which is negative 4, all over 2a, which is 2 times 61. Let me see what k comes out to be in this. So let me get a calculator. Where is my calculator? Right there. So I'm going to drop these values in the calculator and let it do its thing. Alright, so I'm supposed to get a whole number for key, remember? Alright, let's see. I didn't say possible values of key, I just a value of key. The value of key. Alright, so let's see. So I'm with a fraction, and it's 200. Let's do the plus first. Plus square root, not a wrong thing, Mr. Shaw. I want the square root. I want square root up here. Why is it not giving me that? Let's start over. Let's start over. 200 on a fraction, and on the 200 I'm adding square root of 200 squared minus 4ac, 4 times 61 times negative 4. Let's check it again. Not entering the figures right in the calculator. Why is that? And negative 4. Why am I not getting it? All right, 61 times negative. We're subtracting. All right, put it in a bracket. Let's put it in a bracket. Calculator. All right, times bracket negative 4, close bracket. Okay. Then we're going to divide that by 2 bracket 61 close bracket. So I'm getting 3.3 3.29, 3.3, 3.3 initially, 3.3, 3.30, or k equals, I'm going to use the minus now, minus, and that's going to give me a negative 0.019. So, because this is a whole number, I'm not getting a whole number. So I'm wondering if this is incorrect. If we made a mistake, because this tells us that we're supposed to get a whole number for k. That's what this means. K is a whole number. All right? Is it that they wanted us to use the 15? No, can't be. Negative 15 minus 10 is negative 25. This is the equation in the standard form. So the A is k, the B is 1, the C is negative 25. Can I believe on the first question we have a discrepancy? Yep, about discrepancy on the very first question. And we can't work with negative 15. I'm telling you. Wonder if we work with negative 50, we get a whole number. Wonder if that is the solution they want. What if they made a mistake and put a 10 there when it should be a 0? Let's see. Let us try that. Just try that. Let us just try that. Didn't expect to spend so much time on this question, but it happens. So let's just try as if this was a 0 and they intended. They really intended for it to be a 0. But they make mistakes. It can be a typographical error, right? So we put this in purple. Say, okay, in purple, right here, and zoom up. If this was supposed to be a 0 and this is negative 15, would we get a whole number? Let's see. So the equation would have become kx squared plus x minus 15 equals 0. All right. And then the alpha plus beta would have been minus b over a, negative 1 over k, just the same. And the alpha beta still would have been c over a, which is negative 15 over k. All right. And then this equation will come back the same as we have here. So we would have still got this equation, right? And so this equation, because it's 15, this value would have been different, right? So let's put what would have had. So would have gotten this term squared would have been this squared just the same. So I'm going to set about the equation here. It would have been 1 over k squared. And I would have been then doing negative 2 times this, which will become a positive 30 over k, plus 30 over k. That's what would have gotten. All right. And that would be equal to 61 over 4. All right. Let's shift over and work it down here. And then would have multiplied through by the 4k squared again, just the same. Still multiply through by 4k squared. Let's put it here. Multiply through by 4k squared. This would have become 4, just the same. But this would have become 120. 4 times 30 is 120 times k. And then this would have become 61. That would have been the equation. You know, that's what they wanted to do. Crazy! Crazy! Right? I left off a k squared. It's supposed to be 61 k squared, right? Here. When I transpose, I would have gotten 61 k squared minus 120 k minus 4 equals 0. So you see, this now would be able to factorize it and put 61k and 61k 61k and k and 2 and 2 and then what? Wait. Right, I have a minus here, good. Right, and then signs are different with the greater product, the minus sign, which would be this one. So this would have been a minus, this would have been a plus. Let's check if that is correct, because this would be, that would be 122k minus, and this would be 2k, right? And then 122 and 2 gives us the minus 120. So you see, CSEC made an error with this question. They made a mistake with the very first question. Ridiculous, unbelievable. So this one, this can be factorized now. This expression can be factorized. Those are the factors. Those are the factors. And so this will be getting k equals negative 2 over 61. K equals 2. And then this would be your answer, because k is now a whole number, right? So the 2 is a whole number. So this would be your answer. That would be your answer, since k is a whole number. I knew it. Since k is a whole number, that would be your answer. So that is what they intended the question to be, right? But I'm telling you, this 10, the typo, should have been a 0. Wow. And this is number 1. Unbelievable. Unbelievable. I'm going to make a note here. CXC made a mistake here. Should have been 0. This should have been 0. Should have been 0. This should have been 0, not 10. All right, make W actually a whole number. Unbelievable. So this solution will be correct if the 10 is there. So this is what they intended the solution to be over there. Well, such is it. And you know, it's a problem. It's so sad that this is just the first question on the paper. I have a situation, if a student is doing this question and trying to get a whole number, wasting time searching for why they're not getting a whole number because they're doing it the right way here, waste time. How do they get back that time? Unbelievable. CXC, you all need to fix up yourselves. Whosoever is setting these papers, you need to fix up yourselves. You need to do your checks and balances before you release these exam papers. Too often are you making these mistakes on papers. And I'm certain a lot of students are thrown off. Students who know their stuff. Because a student who knows that this transposition is necessary to apply the sum and product of roots theory, it's going to run into problems right here. And if they also are observant to search for a key that is a whole number, then they would have a problem here and might waste time searching for a mistake that they did not make. Unbelievable. How do they get back time for that? How? Unbelievable. And this is the first question on the paper. First question on the paper. Unbelievable. 16 need to do much better than this. Need to do much better. This question says, for this quadratic function, determine the exact value of the maximum point and also the range using the method of computing the square. So they want us to compute the square to find the maximum and get the range. So once we find the maximum value, and it says the maximum point, I see it's a typo. to find the value, the exact value of the maximum point. Should be maximum value. All right, but let's say they're talking about the coordinates, the maximum point by computing the square. All right, so all right, let me make this smaller again. Let's make this smaller again. All right, so I'm going to compute the square. So I'm going to factorize these two terms first with a -5. And careful, you factorize a negative, that becomes a positive. So the g of x, when I factorize it, I'm going to factorize a -5. -5 into x squared. And factorize a negative with a negative, I get a positive 4 on 5 times x. And then I'm putting back this +2 out here. I'm searching for the maximum point using computing the square. I'm going to compute the square inside here now. So it's going to be -5 into x. Half of this becomes 2/5, 2/5. Don't forget to put on your square. And I'm subtracting the square of this, which is 4/25. All of that are inside my curly brackets. So shift this down a bit. And then I must add back this 2. Then I have to expand this again. Consolidate my values and say they don't give a lot of space for it. But maybe I'm writing large. Right? Maybe I'm writing a bit large. So let me just zoom. Let me just make it small and zoom in. Right? Let me make it smaller and zoom in. Let's do it that way. Alright, so this is gonna become equal to, I'm gonna expand with the -5 now. So it becomes -5 into x plus 2/5 squared. -5 times this first, it becomes a positive 4/5, because 5 into this is 25. 5 into 25 is 5. So I get the 5 here. And then I'm gonna add this 2. But that 2 is the same as 10/5. So this 2 is the same as 10/5 right here. What did I do here? I took half of this value, just remind ourselves of the process, and then I square this value, shift this down, show that I squared. Then I subtract the square of this value, square that, and subtract it. That's the process of computing the square after we factorize. All right, and so these then become equal to -5 into x plus 2/5 squared. This is now 14/5. So since I want the maximum point, not just the maximum value, this is the maximum value, which occurs when this expression is equal to 0. That expression is equal to 0 when the x equals the negative of this. So it's when x equals the negative of this. That's where the maximum point is. So let's write it down. The maximum point will have coordinates. This is the y value, which occurs when the expression in here is 0, which is when the x becomes the negative of this. So that's -2/5 is the x value. And the y value, the maximum point, which is the maximum value, is 14/5. 14/5. So since 14/5 is a maximum value, it means that the range on the function, the range, is that the g of x has to be less than or equal to this maximum value of 14/5. That is the answer right there. And that ends number 1. Didn't expect to spend so much time on it because of this question right here that was set with an error. This question, unbelievable. Very first question on the paper, set with an error on it. I'm sad for students because of this. CSEC need to do better. CSEC, you need to do better. You need to do better. can have a question, can have a mistake on the very first question of an exam paper. This alone can set a bad tone for students in the exam on the first question, a question that is supposed to be straightforward and easy. They come up with a result that you're not expecting, and it's because the question is erroneous. Anyway, see you in the next question.